Welcome back to our astronomy series. Today we're diving into one of the most awe-inspiring topics, the night sky. Specifically, we'll be exploring constellations and celestial coordinates, two essential aspects that have helped humans navigate the heavens for millennia. The night sky has captivated humanity for thousands of years. Ancient civilizations used the stars not only to tell stories and predict events, but also to navigate and keep track of time. Today, constellations and celestial coordinates serve as vital tools for both amateur and professional astronomers. In this lecture, we'll break down these concepts so you can better understand and appreciate the beauty above us. Part 1. Constellations, the stories in the sky. Let's start with constellations. If you've ever looked up at the night sky, you've probably noticed patterns of stars that seem to form pictures. These star patterns are called constellations, and they've been recognized and named by cultures around the world for thousands of years. A constellation is essentially a grouping of stars that form a recognizable pattern, often resembling an object, animal, or mythological figure. Think of constellations like the connect the dots of the night sky. Constellations have deep roots in human history. Ancient civilizations such as the Greeks, Romans, Egyptians, and Chinese all had their own sets of constellations. The Greeks in particular are famous for associating constellations with their myths and legends. For instance, Orion the Hunter is one of the most well-known constellations. The story behind it is tied to Greek mythology, where Orion was a great hunter placed in the sky by Zeus. Today, astronomers officially recognize 88 constellations that cover the entire night sky. These are standardized by the International Astronomical Union, IAU, and are used globally. Some famous constellations you might recognize include Ursa Major, which contains the Big Dipper, Orion, and Cassiopeia. Part 2. Celestial coordinates, mapping the sky. Now that we've covered constellations, let's move on to celestial coordinates, the system we use to map and locate objects in the sky. Why do we need celestial coordinates? Just like we use latitude and longitude to pinpoint locations on Earth, astronomers use celestial coordinates to map out the positions of stars, planets, and other objects in the night sky. Because the sky is constantly shifting as the Earth rotates, a fixed system is essential for accurately identifying the positions of celestial objects. Imagine an invisible sphere surrounding the Earth, with the stars projected onto its inner surface. This is called the celestial sphere, and it helps us map the positions of stars and other objects relative to the Earth. The celestial sphere has two poles, the North Celestial Pole and the South Celestial Pole, which are extensions of Earth's axis. The celestial equator is an extension of Earth's equator onto the celestial sphere and divides it into the northern and southern hemispheres. Right ascension and declination are the two key coordinates used in this system. Right ascension, or RA, is the equivalent of longitude on Earth. It measures how far an object is from the vernal equinox, the point where the sun crosses the celestial equator during the spring equinox. RA is measured in hours, minutes, and seconds, and there are 24 hours in a full circle around the celestial sphere. Declination, or dec, is like latitude on Earth. It measures how far north or south an object is from the celestial equator. Declination is measured in degrees, with positive values north of the celestial equator and negative values south of it. For example, if you wanted to find the star Betelgeuse in the sky, you would use its right ascension and declination coordinates. Betelgeuse has an RA of around 5 hours and a dec of 7 degrees north, making it relatively easy to spot in the constellation Orion. So why do these concepts matter in modern astronomy? Well, constellations and celestial coordinates help us in several important ways. Ancient sailors used constellations like the North Star, Polaris, in Ursa Minor to navigate the seas. Even today, the stars remain a reliable tool for finding direction when technology fails. For astronomers, celestial coordinates are crucial for identifying and tracking celestial objects. Whether it's a distant star, a planet, or a galaxy, knowing the RA and dec allows us to pinpoint these objects in the vast night sky. If you're into astrophotography, understanding constellations helps you plan your shots. Knowing when and where a specific constellation will rise or set is key to capturing those perfect celestial images. In summary, constellations and celestial coordinates provide us with a framework for understanding and navigating the night sky. Whether you're tracing ancient myths among the stars or using precise coordinates to find a distant galaxy, these tools help us unlock the mysteries of the universe. Thank you for watching this quick lesson on the night sky. Don't forget to subscribe for more bite-sized insights into the wonders of astronomy. Clear skies and happy stargazing!